Okay, so yes, like I mentioned, we'll be looking at the solution to this. We'll start from there, and we are going to also look at apply some of the things that we have done here in the area of questions on KSF. Alright, so for this question we have find the sum, or let me just try to review what we did in the summer. We were able to look at the concept of addition, and in the concept of addition we see that addition is commutative, and it is also what, apart from being commutative, commutativity means when you have 2 plus 3, it's still the same thing as 3 plus 2. So that is what we were able to look at then. So that's commutativity. We also look at the area of associativity. Commutativity means you can flip it. When you flip numbers, it doesn't affect our results. So this is still the same thing as this. And we also looked at the case of associativity. The order with which we have added doesn't matter. So if we are adding, we have 2 plus 3 plus 4, and want to add 3 plus 4 before we add it to 2, it's still the same thing as adding 2 and 3 first before we add it to 4. So these concepts are very, very important. We need to continue to eat on it. So for the first question here, find the sum. You can draw this, find the sum here. Then we also looked at how we can add easily. So there are different ways which you have also learned for those people that have gone through the IXL. You have also been able to add that. So you have been able to learn that. So in this case now we are adding 785 plus 212. So the process we have learned that in different ways. So whichever one you apply, you are correct. There's no problem about that. So if you like, you can use this approach, 212, and we have 799. So that doesn't actually matter, but from what you have also learned in IXL, yes, from what you have learned in IXL, you can easily add 200 to this to make it to become 985. Then you add 10 to it, it becomes what, 995. Before you can now add 2 to it, and it becomes 997. So that's another systematic way of adding. You add based on 100 first, followed by 10, and then so you can see we have 200. So we can move to the next one, 2 in this manner. So in that case, if you use the number line that they have mentioned here, it means you first add 500. So 328 plus 500, that's the first thing you add, and in that case you get what, 828. We need actually to be able to do it in different manners. Yes, because each approach will be useful when you get to some areas. So that is why it may be necessary to be able to use all the approaches. So having added this, which will give us 828, you can go for 60, add 60 to it, and that will give you what, 888, and then add 4 to it. And if you are adding 4 to it, you can easily add 2 to this one to give us 890 plus 2, that's 892. So the answer is 892. So all these ones we just need to jump some. So okay, so which one? Number 3 is also in the same form. Number 4, we have which number makes the equation true. So in this case now we have they want to apply what we have learned before. So in this case, it said which number makes the equation true. So what happened? They have actually brought this 8 to this place. It means they are swap or flip. They have swap actually. So 8 is the unit digit here, They have, what they have done, the 8 is the unit here, so they have swapped the unit digit. So 8 will come here and 7 will come here, so it means it becomes 787 plus 8. So the missing one here is 787. So they have only tried to swap the digit, the unit digit. The unit digit here is 8, the unit digit here is 8. So if the unit digit here is 7, so what we are just trying to do is that it's still similar to the concept of what do we call it, commutativity. So they have only played with the unit digit there. So meaning 7 plus 8 is same thing as what, 8 plus 7. So they have only played with the unit digit there. So the question number 5 here, it says which number makes the equation true? Which number makes this equation true? So this is 494 plus what? So what have they done? It means they have, this is 394. So they have added 100 to 394 to make it to be what? 494. So if you have removed 100 from, if you have added 100 to this, then it means to balance it up, you must remove 100 from this. Just like when we have 60 plus 40, we give us 100. If you remove 10 from here to give us 50, it means the 10 you have removed from here, you must add it to this to make it to be the same thing. The same thing if you have removed 20 from here, for example, you have 30 here. Then the 20 you have removed from here, it must be added to this to give us 70. So 30 plus 70 is still the same thing as 100. So that's the concept, that's the way they want us to see it. So it means when you are adding two numbers together, if you reduce one, the other one will what? Will increase. The other one will increase. So that's a relationship. When we move on, we later see what we call relationship or variation. In junior secondary school topic, they call it variation. And we have different kinds of variation. They say one, we have what we call direct variation. They are direct. Direct means if one should increase, the other one we must also increase. So that is what we mean by direct relationship. So maybe when we have something of that nature, we may give us examples of where we can see that we have direct relationship. In most cases, look at the height of a student, the height, especially of children, and the age. You know, when a child is of age, maybe age 3, and they measure the height. So maybe when they measure the height is just possibly, if it is possible, maybe 1 meter. You know, by the time the age increase to like 6 or 7, it means surely the height too is expected to increase. So we say that the height and the age, they have direct variation. They are directly related. Is that clear? So that's an example of what you mean by direct variation. So in that case, the height can be maybe 3 meters, if it is possible. So that is, okay. Do we? No. Sorry. Do we measure in that? Okay, yes, we can still measure like that. 1 meter is too small. 1 meter is too small. Or when you talk about children or people, you can talk of measuring in feet. Maybe 2 feet for 3 years old, and 3 feet for 7-year-old. So that's an example. So in that case, when one increase, the other one increase, that's direct variation. But in the case of addition here, when one increase, the other one must reduce, and that is what you can see here. The same thing we observe when we are trying to add numbers. When we say that pairs of 10, we say 1 plus 9 will give us 10. By the time you increase this one, you reduce this, it becomes 8 to still give us the same 10. When you increase this to 3, you reduce this. So this is a kind of indirect variation, or we say inverse variation. So indirect, when one increase, the other one so this one, when you add them together, will still give you 10. So that is okay. So let's move to the next area. So look at this. They use the property to find the sum. Now what property are they trying to use here? 45 plus 23 plus 85. Now I expect that these questions are simple, but because they want us to use that concept, so and that is what you can see in this question, the concept. So it's very, very important that we look at that concept. So okay, so in this case now, I think it's clearer now. Okay, so if you look at this now, use the property to find the sum. 45 plus 23 plus 85. What do we expect here? Yes, we expect the concept of associativity. We want to add three numbers. So we can actually we have 45, we have 23, we have 85. 23 is taken, 23 that is here, this is 23. 85, this is 85, this is 85. So it means what they have actually done is to have use the principle of what do we call it, commutativity, to swap between 45 and 23. So if this is 23, then it means 45 will be here. So, and in this case, it's still the same 45 that is here. And why did they do that? Don't forget, because they find it easy or easier to add numbers ending in 5 and numbers ending in 5. You can just drop the 5 here to this one to become 90. 90 plus 40 is 130. So it means when you add 45 and 85, it will give us 130. And 130 plus 23, you can easily add it to give you 153. So it's actually possible for somebody to add in this manner 45 plus 23 and say 45 plus 23. 45 plus 23. You get it? And in that case, you'll be having, it will be 68. 68 plus 85. You can see how difficult it is to, so you can even easily make mistake. So in that case, that's why we prefer to use this particular approach. Okay, so that is what we see there. Now the next question is still in the same manner, but here we have four numbers. 61 plus 39 plus 23 plus 67. So and what they have done is to take them to this and this. That's 61 plus 39. So 23 plus 77. So it means the sound that is missing here. And then look at this. They can easily add this because they are pairs. So 1 plus 9. If you remove this one here, bring it here, it becomes 40. 40 plus 60, that's like 100. And the same thing here, when you do the same thing, this is also 100, and you have 200. So
what we have just done here is that we have looked at the simpler way of adding numbers together. Instead of just adding anyhow, we look for numbers ending in pairs of 10. 1 and 9 are pairs of 10. 3 and 7 are pairs of 10. So you can easily add them together. Alright. So the same thing we have here. So this is about multiplication. So I'm trying to just quickly go through this concept as a kind of revision, so to also strengthen what we have known before, so that you can apply it in other difficult areas. All right, so use the distributive property of multiplication to find the missing number here. So we have 6 times 7. So in this case now, this is 6. You can see 6 is here, 6 is here, 6 is here. So since we have plus here, don't forget that we add a concept, that's distributive property of multiplication. That when you have, for example, we have 2 multiplied by 3 plus 4. That is the same thing as 2 multiplied by 3 plus 2 multiplied by 4. The 2 multiplies everything inside this bracket one after the other. So 2 multiplies 3, 2 multiplies 4, and it will give us 2 times 3, which is what? 6. 2 times 4, which is what? 8, and that will give us what? 14. So anytime you see this, you can easily interpret it to be this. And anytime you also see the second one too, you can easily interpret it and say 2 is common to them, 2 times is common. So it means anytime you see 2 times 3 plus 2 times 4, you can easily interpret it that is same thing as 2 times. 2 times is common to both. Then 3 plus 4, which is what? 2 times 7. So what they have given us here is that they have given us from this end here. Can we break it down? It's still the same thing as 6 times 2 plus what? You know, in this case now we have 6 times 2 plus 6 times what? Something. So we can easily say that we have 6 times 2 plus a number to be the same thing as 6 times 7. And what does that mean? This is 6 times, this is another 6 times. We are comparing now. You get it? We are comparing. Before they gave us the left hand side, in mathematics, when we have the left hand side, it must be the same with what we have at the right hand side. And left hand side and right hand side are usually separated with what? Equality sign. Equality sign. So the equality sign. So this is the equality sign here. Okay, so we have 6 times 7, same thing as, according to what we have learned before about distributivity, 6 times 6 times, you can bring it out. So when you bring it out, 6 times 6 times, you can bring it out. So after bringing that out, then it means we have 2 left here, which is the 2 plus what? Now when we are comparing, this is 6, this is 6, this is 7, but we have 2 here. 2 plus what will give us 7. So everybody knows that 2 plus what? 5 will give us 7. So it means the missing number here must be 5. So that it will become 6 times 2 plus 5, which is 7. Is that clear? So that is what we mean by that. So it means 5 is what is missing here. 5 is what is missing. The next question, they say the sum of two numbers is 15 and their difference is 9. what are the two numbers. Okay, so here they just want you to look at it, play around it. What are those numbers? You can think of it. What are those numbers that can give us 15? You know that 8 plus 7 can give us 15. Exactly. And by the time I continue to remove 1, add 1, I'm still going to get 15. If I remove 1 from 8, for example, I'm going to have 7. Plus, if I add 1 to 7, because I remove 1 from here, I need to add 1 to this. This will be 1. So 7 plus 8 is still the same thing as 15. Remove 1 from 7, you have what? 6. Add 1 to this, you have 9. It will still give us 15. Remove 1 from 6, it is what? 5. Add 1 to 9, it will give us 10. It will still give us 15. Remove 1 from 5, you have 4. Add 1 to 10, you have 11. It will still give us 15. Remove 1 from 4, you have what? 3. Add 1 to 11, you have 12. It will still give us what? 15. Remove 1 from 3, it is what? 2. Add 1 to 11, 12, it is what? It is 13. It's still 15. Remove 1 from 2, you have 1. Add 1 to 13, you have 14. It will still give us 15. And then lastly, if you remove 1 from 1, you have 0. Add 1 to 14, you have 15. It will still give us 15. So here they said the sum of two numbers is 15 and their difference is 9. Can you now look at the difference? The difference between 8 and 7 is just 1. You know, when we say difference, it means we are subtracting. The difference between 7 and 8 is still 1. The difference between 6 and 9 is what? Is 3. We are looking for the difference that will be 9. The difference between 5 and 10 is what? Is 5. That's 10 minus 5 is 5. 11 minus 4. What's the difference? 11 minus 4. You realize that the answer is what? Is 7. The difference between 3 and 12. And you see that that is what will give us 9. So I hope you get what I'm trying to explain there. So what I'm trying to explain is that this actually, if you look at this question, when a student, a senior secondary student should see this question, the interpretation it will give it is simultaneous equation. But it's not necessary we take it to be simultaneous equation, because a primary 4 student, a primary 3 student, even 5 may not know anything about simultaneous equation. It takes extra effort for a primary 5 or 6 student to know, to be able to solve what we call simultaneous equation. But yet we can still solve this question without simultaneous equation. So, and that is what I've done. So we have been able to look at the sum. This is the sum. But for the difference now, we look at, what did I do? I looked at the different possibilities that we can have. You get it? Different possibilities that we can have for the sum. And how do you get it? By adding 1, subtract 1, add 1, subtract 1, add 1, subtract 1. Now, so for this now, let's see the difference. For the difference, in this case, what do? We look at the difference. 8 minus 7, what will it give us? It will give us 1. 7 minus 8 is the opposite of 8 minus 7, that is minus 1. Although the difference here, they are not after whether it is negative or positive. The difference is 9. Exactly. So they are not, when we say difference between two numbers, it means the greater minus the smaller. So I think that's the concept I'm going to use here too. So the greater minus the smaller. So when we still want to find the difference here, we still use 8 minus 7, which is the same thing as what? 1. Okay, so so it's still 1. So here it will be 9 minus 6, and we know that 9 minus 6 is 3. 10 minus 5 is what? 5. 11 minus 4 is what? 7. So it is 12 minus 3 that will give us 9, and that is what they require here. So they say, what are the two numbers? You realize that others will not give you 13 minus 12 minus 2 will give us what? 11. 14 minus 1 will give us what? 13. 15 minus 0 will give us what? 15. So the only one that will give us is 12 and 3. So the answer is 12 and 3. Okay, so because of time, because I still want us to treat some other concepts, as in I want us to use let's see, let me see if I can. Okay, yeah. Okay, yes, there are some questions here I want us to actually look at. Okay, now look at this question. This is a KSF question because we have a few minutes more. Okay, so look at this question. Let me see, how can I make it bigger? Okay, I think this is still better. Okay, so look at this question. This is question on KSF for primary I think 3 and 4. Yes, this is for primary 3, primary 4. All right, so I hope Wusu is listening. So look at this question. It says 7 cards with the numbers from 1 to 7 are placed in these 4 overlapping rings. So these are rings. This is a ring. The circles are called rings. So that is what they mean. 7 cards with the numbers from 1 to 7 are placed in these 4 overlapping rings. If you add up the numbers of all cards in a ring, the result is always 10. Meaning, in this particular one, for example, if you take the first one, yes, if you take the first one here, let me, okay, yeah, if you take this circle, we have 2 numbers there, we have 6 and this. When you add them together, they must give us 10. That's what they mean by that. The 7 cards with the numbers from 1 to 7 are placed in these 4 overlapping rings. So these are cards 1, 2, 3, 4, 5, 6, 7. 7 cards. So if you add up the numbers of all the cards in a ring, the result is always what? 10. Meaning that this is a ring on its own. If you add up 6 and this number, it will give us 10. Look at this ring, for example. Now, Usu, can you tell me how many cards do we have in this second ring? Yes, I'm listening. Okay, 3, yes, you are correct. Okay, You are correct. So we have 3 there. The same thing here, we have 1, 2, 3. Now, but for this, we have 2 rings, 2 cards, abi. So when you are given problems of this nature, the one that can easily be solved are the ones with 2 cards. 2 cards. So look at it. This one, this ring. Let me label the ring. This is ring A. This is ring B. This is ring C. This is ring D. Now look at it. The one that is easy to fill is the ring A. Ring A has 2 cards, and they said that the 2 cards must add up to give us 10. So if this one is 6, what do you think will be the second one here? What number will be here? They have said they have numbers. All these cards, they numbered it 1, 2, 3, 4, 5, 6, 7. So they are doing, is it hide and seek that you call it? Yes, that is what they are trying to do. They have covered it. So they want us to detect it. So our knowledge of mathematics, knowledge of normal logic, that is what we are going to use, our knowledge of mathematics. They have said, if you pick this particular ring, for example, if you add up the 2 cards there, they must give you what? They must give you 10. And this one is 6. What do you add to 6 to make it to become 10? Surely it is what? It is 4. So it means 4, we go for this. 6 is already taken. This is 6. 3 is also taken. This is 3. So it means 4, we go for this. So that when you add up 6 and 4, it will give you what? 10. So we are done with A. For B, you cannot jump into B now because B has 3 cards. 1, 2, 3. 1, 2, 3, and we only know just one of it. So it's not easy for us to get 2 answers at the same time. The same thing to C. C has how many cards? 3 cards. 1, 2, 3. So we cannot go there too because we can't get 3 answers at the same time. If you cannot get 2 answers at the same time, it means you can't get 3 at the same time. So it means we now come to D. Luckily for us, D has just 2 cards, and one of it is 3. What will you add to 3 to make it to become 10? The straight answer, the direct answer is what? 7. When you add 7 and 3, it will give us what? It will give us 10. So it means we have been able to fill 2 of the cards. We have been able to fill the one that's supposed to be 4 and 7. So how do we fill the remaining ones? How do we fill the remaining ones? Now look at it. What are the 3 numbers? We have 3 cards left. This card, and this card. So what do we do? Which one is the next one that we fill? Now look at it. Look at the one that has question mark. If you look at this is 7. Now actually, as a primary school student, you may feel, I don't want to disturb myself, let me be doing try and error. Let me put 1 here, whether it is going to work. Well, no problem, but it's better that you see how you can easily do it, how you can stress yourself to do it. So what do we do? Okay, so let me change. Yeah, so in this case now, we know that this is 7. 5 can never be here. If 5 is here, it means 5 plus 7 is more than 10 already. It's 12. Exactly. So also the remaining 5, you know, we have 1, 2 and 5 left. So 5 cannot be here because when you add 5 to 7, it will what? It will become 12, which is more than 10. 5 cannot also be here because this 1 and 7 were in the same ring. So when you put 5 here too, it cannot go. So it means 5 cannot be here, 5 cannot be here. The only place that 5 can be is here. So put the 5 here. Is that clear? Now, so when 5 is there, what's the next thing? The next thing is to see. We want to fill 1 and 2. Now, since 5 is already occupying this place, let's look at the B. Ring B. Ring B has 4 and 5, which will give us 9. We have just 1 left to make it to become what? 10. So put the 1 here. So it means the 1 will be here. And so we have 4 plus 5 plus 1 will give us what? 10. Correct. So let's see what happened here. In this C now, we have 7 plus 1, which is 8. The remaining thing will be what? 2. And luckily it is 2 that is left. So 2. So you can see the systematic way with which we have filled the what? The rings. I hope you understand. That should be Sumayabi. I hope you understand what I've explained.
Yes, sir.
Okay, so that is the way in which you need to approach it. You can mute your mic. Okay, thank you. So this is 1 that will be here. So the question they ask is that what is the number? What number is on the card with the question mark? Which is what? 1. I hope you understand that. So okay, you have said you understand that. So possibly maybe we can do one more question before we call it a day. Yes, let's add one more question to it. Let me pick another question. Okay, so look at this question. Lucy weighs building blocks, or Lucy weighs building blocks and obtains the following values. These are the values. What did they do here? Now what they did here is that they measure, look at this is triangular in nature and this is circular in nature, and they got 200. And this is triangular in nature and circular in nature, and they got 100. And this is what do we call it? This is triangular, rectangular and triangular, and we have 240. So they said if they put the 3 together, what will we have? So how do you want to approach this? Also, a secondary school student we prefer to use simultaneous equation to do this, but for primary school students we have not done simultaneous equation. You don't even know what it's about. So this is like, we can see this one as a puzzle. Yes, how do we see it as a puzzle? It's a puzzle in which the first one is rectangle. This is a rectangle plus circle will give us 200. This is a triangle plus circle will give us what? 100. And the last one, a rectangle plus what? Triangle will give us what? 240. Now Sumaya, when you see something of this nature, the best approach you can give to it. It may not be easy for you to think of. Actually, in your mind, you'll be thinking, what did they add? Did they add 100 plus 100 there to give us 200? You don't need to disturb your mind like that, because in that case, you'll be doing trial by error. You want to avoid trial by error. If you are going to do it at all, you do it for something that is meaningful. Look at the question we treated the other time. We looked at it, we pick 5 and say, because we have 7, so 5 cannot fit in there, cannot fit in there. You can see we are able to have an argument. So in this case too, what do we do? What do you observe? Look at all the items given. Let's see how many times were they given. This is a rectangle here, 1, another rectangle here, 2, circle 1, circle 2, triangle 1, triangle 2, meaning that all of them, if we need to add everything together, it means we are going to have 2 triangles, exactly 2 triangles or 2 rectangles. We have rectangle, rectangle, we have triangle, triangle, we have circle, circle. And if you add everything together here, if you add everything together, 200 plus 100 will give us 300, plus this, it will give us 540. When you look at it, you can see this plus this are the same thing with what you have now. So it means they are going to share this 540 equally, because they are the same thing. This is triangle, rectangle, rectangle, square, triangle, triangle, circle, circle. So it means if they want to share this 540, they share it equally. So the upper part we collect 270, and the lower part we collect 270, which is sharing equally. And if you look at this, what they have asked us to do is to find this. So it means the answer to this is 270. Look at it. We have not been able to, the calculation we have only done is to add, and we divide. If you divide 540 into 2, we have what? 270. Look at that. As simple as that. So I think this is where we are going to end the class for today. I'm going to, for your assignment, I'm going to send more of this for you to look at. So also we'll be using the Google Classroom. I've created a class in the Google Classroom for our students, and we'll be sharing the material with you there. So the Google Classroom I've created, I think you can just go to your phone and then go to Google Classroom, check for Google Classroom app. Google Classroom app. So if you check for that, let me see for your, okay, I'm going to, okay, I didn't even ask. I hope you understand what I've done here.
Yes, sir.
Okay, so I'm going to, let me go to Google Classroom now to show you. Okay, and now, okay, I think let me stop recording here now.